Hello, guys. Welcome to grade 10 Physical Sciences. Today, on the skills for science, we are looking at unit prefixes. So, these are the letters that really come before our units to replace the quantities. For example, 1,000 of something will always be referred to as a kilo of that thing. Now, let me remind you of South African slang. Um, and I think this one is yeah, South African slang. Let's take South African slang. For example, South African slang, when you have 1,000, you will say you have steen, right? You'll say you have steen. And this is of course slang in the Pretoria region and Pretoria and majority of the Northwest and even Gauteng, right? The rest of Gauteng, perhaps you try that Opetistena, right? Opetistena or Onalestena. This is to say you have 1,000, right? Two stena, 2,000. You get that? So these, so these are prefixes that we use even in science. You see, science also has that thing. Of having slang as well. Hey, I man, I cannot say I have 1,000. Nzoti, I have I have a kilo, right? I have a kilo because these are really coming from the Greek language, isn't it? So I hope you guys now see it. You have istena or onalestena means you have 1,000. Now even science has that thing. You see, even science has that thing. So so now let's look at the prefixes, guys. So let's look at the prefixes that we deal with in science and then what they mean. Okay. So the meaning of these prefixes as well, quantity, right? So we have tera. So we begin with tera, terabyte. Tera, it has a capital T. So tera means 10 to the 12. Ooh, I will not be writing 12. I will not be writing 12 zeros, guys. I'm sorry, I cannot be doing that, right? But because before this unit we did scientific notation, you guys now understand, right? Or maybe let me. 12, 10 to the 12 means 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. That's tera. All right. So instead of writing whatever tera, I will just say this is 1 tera. Right. So this is 1 tera. Instead of writing this, I can say it's 1 tera. Right. It's 1 tera. Tera of something. All right. Then we go to giga. Giga is small g. So giga. Okay. But I think, no, it's not a small g. It's a capital G. It's a capital G. Thank you. It's a capital G. Even this tera, it's a capital T. Right. It's a capital T. So giga is a capital G. Giga means 10 to the 9. So what does it mean? It's 1, 2, 3, 1, 2, 3, 1, 2, 3. So you see, when you have 9 places, you can say it's a giga. So 10 to the 9 means giga. Okay. Then we have mega. Mega, you also refer to it as a million, right? So this is 10 to the 6. 10 to the 6. This means you have, after 1, you have 6 zeros, right? So mega means 6 zeros. 10 to the 6. Okay. 10 to the 6. So you have mega rent, 1 mega rent, 1 million rent, eh? Okay, guys. Now we then have kilo. It's a small k. You then have kilo. It's a small k. Kilo means 10 to the 3, which is 1,000, right? Like we said in our opening slide, it's 1,000. Kilo means 1,000. Then we proceed to hecto. We proceed to hecto. Hecto means 100. Hecto means 100, which is 10 to the 2, right? Which is 10 to the 2. Then we have deca, small d, of course, and it's DE. Sorry, DA, not DE. It's DA. Then what is this? This is 10 to the 1, which is simply 10. Okay. Which is simply 10. Okay. which is simply 10. Now, let us then look at the small ones. The small ones. So these are the big ones. The small ones, let us begin with deci. Let us now look at deci, is small letter d. Deci means 10 to the negative 1, which means it's 0, comma, what? 0, comma 1, isn't it? Then we move to centi. Centi, small letter c. Centi means 10 to the negative 2. What is 10 to the negative 2? It is 0, comma 0, 1, isn't it? It is 0, comma 0, 1. Then we have milli. Milli, small letter m. What is that? Milli, small letter n, is 10 to the negative 3. What is this? This is 0, 0,001. Guys, I hope you now see why instead of saying 0, 0,001, we write milli. Then you have, let's try micro. Micro has the Greek letter mu, has the Greek letter mu. So this is 10 to the negative 6. Please let me not write 6 decimal places, okay? Then we have nano. Then we have nano. Nano is small letter n, which is 10 to the negative 9. And maybe let's conclude by pico. And there's more, of course. Pico, it's small letter p, which is 10 to the negative 12. Okay, so these are the units, these are the unit prefixes. Now let's try some examples. Let's try some examples. Now, example, write this in unit prefixes. Write the following in unit prefixes. In unit prefixes. Okay, number 1, we have 2, 4, 6, 9, 7, correct to 2 decimal places, okay? Correct to 2 decimal, okay? 7, 8, 9, 2, 4, 1, 2 meter. And then, meter. Now, I'm going to say bytes. Okay, I'm going to say bytes. Okay, this B is for bytes. So now we're talking data. And then we're going to talk 0,00789 liters. And then number 3, we're gonna try 6,742,31 grams. Number 4, we're gonna try 0,1426 seconds. Okay, so let's get our solutions now. Let's get our solutions. So our solutions, guys, let's try. Number 1, let's see. Number 1, we have 2, 4, 6, 9, 7, 8, 9, 2, 4, 1. So let's see how many decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Byte. Right? 9. So you must look for this. What is this? So this means this is 2, correct to 2 decimal places. 2, 4, 7. Now 9 places. 9. You're gonna look for one that corresponds to 9. It's giga. Right. So this is gonna be 2,49 gigabytes. 2,47 gigabytes. This is your data. All right, guys. This is your data, isn't it? This is your data. 2,000, or rather 2469789 bytes corresponds to 2.47 gigabytes. That's your data. All right? Data. Oh, Vodacom, Telcom, MTN, Cell C. That's you. Right? That's your data. isn't it? Now let's try number 2. Number 2 was 0,007892. 0,007892 liters. So what do we do now? We move to the right. 1, 2, 3. So this is 7,892 times 10 to the what? Times 10 to the minus 3 liters. Ooh, what is this, guys? This is correct to 2 decimal places. This is 7.89. Ooh, 10 to the minus 3. What did we say? 10 to the minus 3. We called it milli. 10 to the minus 3. We called it milli. So this is 7.89 milliliters. All right? Milliliters. So for this one, in case you're wondering why didn't I do it like the second, let me go there. So we are saying this is 2,469789241 times 10 to the 9b, which is basically 2,47 gigabytes. Isn't it? Perfect. 6742,31. 6742,31 grams. All right. Now what do we do? It seems we must move to the left. So we're going to say this is 6,74231 times what? How many places did we move? 1, 2, 3 times 10 to the 3. We're moving to the left times 10 to the 3 grams. What is 10 to the power 3? 10 to the power 3 corresponds to kilo. So this is correct to 2 decimal places. This is 6,74 kilograms. Isn't it? Perfect. 0,1426. Number 4 is 0,14. 0,1426 seconds. We are now moving to the right. What is this? We have to move one place only. So it'll be 1,426 times. Since we are moving to the right, it'll be to the power negative 1 second. So what is this? This is correct to 2 decimal places. 1,43. Remember, guys, if you are still struggling with rounding off, there's a video. I'm going to drop the link. It's going to let it pop. It's going to pop, okay? So 1,43 times, what did we say 10 to the minus 1 was? It was deci. So it's going to be 1,43 decisecond. Okay, let's go confirm. Here is it. Deci. Deci is 10 to the negative 1. Do you guys see this? And guys, this is how we write our prefixes. Okay, this is how we write our prefixes. So with that being said, ours is done and bye-bye.